Right, howdy. So what are we looking at today? We are looking at you turning a corner while running and not noticing that there's a refrigerator there on a dolly. And when you hit it, you're going to come to a complete stop. Then the refrigerator is going to start moving. All we want to figure out here is how fast that thing's moving. So this is going to be a collision, and collisions all conserve momentum, so we have to do conservation of momentum. Now, you may remember me saying in the little lecture segment that with conservation of, or with a collision, conservation of momentum is usually not enough. And it isn't, but what we have here is a second condition. So our condition here is that, originally you are moving at, this is not working out very well, the speed v, the refrigerator is moving at 0. And in the end, you are not moving at all. So you're moving at 0. And the refrigerator is sliding away at some speed u. So the condition I have is this, that you have stopped going, so that your final velocity is 0. So that is enough to let us solve for the final velocity. So that's sort of the simplest sort of collision, is when one thing stops and the other starts going. If they have the same mass, it's even easier. But, it turns out, and I don't know if you've ever tried this, you do not weigh the same as your refrigerator. So, I don't think. So what we're going to do is we're going to have you weigh a different amount. So we're going to give you 150 pounds, which is more like the average of your weight and mine. And then we'll do I weigh about 200 pounds. And we'll have 250 pounds for the refrigerator. And then you're going to hit it going at 10 feet per second, which I have no idea how fast that is. And then it's going to start moving. So that's basically what we have to do. And we're conserving momentum. Momentum is just the mass times the velocity, right? And we're adding up the initial momenta. U plus it equals u plus it. Just happens to be that it's mv plus 0 is equal to 0 plus mu, capital Mu, because let's use capital letters for the refrigerator, because it's bigger than you. All right, so then, if you don't believe me, see if you can empty everything out of your refrigerator and you can actually fit in it. It's bigger than you. Okay, so let's see. You know the elephant joke, I'm sure, right? Yeah, you know the elephant joke, so I won't give it to you. I really want to, though. But you're not 10 anymore. Let's see. So the mass here is your mass, so we'll put that number in here, that you weigh 150 pounds. Probably plus or minus 50. But we can't do the plus or minus because that'll give us too huge a range. Where we're using math, if we're going to say, yeah, it's going to go, but it's going to go slower, which is what it's going to do. You're going 10 feet per second. The refrigerator weighs 250 pounds. Pounds of mass. It's the final speed u. How do we take care of this? We divide through by 250 pounds. Right, so let's see, that guy is gone, and then we have 150 over 250 is 3/5 times 10 feet per second, and that's going to give me 6 feet per second, so it's going to go slower than you. I just said that. So more or less that's all that's going on with this. So that's sort of the simplest way to have a collision done. and it's pure conservation of momentum. So it's pure conservation of momentum. It's not cut by anything at all. All right. Well, that was fun. I'll talk to you again soon.